Hey, what up, dudes? Alright, here we go. Alright, so we're picking up where we left off, duh. Yesterday, did some work off stream. Did almost 2 hours. I don't know, I can't even remember, honestly. But I know I did a good bit. We verified there's no code in client which sends out resend requests at all. We deleted handle receive data, depopulate the sent data storage dict function as it was determined that it's not needed. Made minor modifications to handle receive data and added some to-do tasks in a few places inside of it. Made various quality of life improvements in client to reflect the changes similar or same code in server while it is fresh in my mind. And change removed about 50 to 100 lines. And then updated things to do. So yeah, we hopped over to client, made modifications there. Basically, like the same things that we did in server, and I guess it was good to do because it was already like fresh, it's fresh in my mind. So yeah, I did want to see if we could get rid of maybe this receive data and like the attribute itself, and just use the local variable. I don't know. I know that we use. I know that we use that list to save the data. It's in like a. Let's see, where is it exactly? We don't use this anymore, so we can get rid of this. Should be in save logic, maybe. If we go all the way to the top, we don't use path here actually, so apparently we can get rid of that. And we don't even use custom logger in. Well, we do need to add custom logger for that then. File is going to be save logic, so SA, and then serialize and insert function. This one's just going to be replaced with that function's name. So this is the list I was talking about, the master save object dictionary. And I wonder, could we just, instead of using this as like an attribute, could we just pass in the local variable instead? Or do we have to use the attribute itself? Wait, this is the receive data storage. That doesn't even exist anymore. Hold up. I know there's other things from client though, right? Like, do we not store the... Surely... Okay, there it is. The received cal2. So that's the only one we actually store. Is the received cal2 plus. Let's see over here. What is the one that I'm trying to remove? This one right here. So this is received data and receive change attribute list. So we don't even save these. So like if we don't even save it, like do we need to have it as an attribute? Or can we just have it exist as a local variable? Because so we have, okay, it's an attribute obviously, but does it have to be? Or could we just... Okay, so we're not converting received data to client received data. So that's fine actually. That's okay. I thought we were doing what we did on server where it's basically just like a duplicate variable for something, you know, like it's already assigned to the namespace a local variable called received data, and then we have the attribute again to like it's the same thing twice. Okay, so we don't need to worry about that actually. I don't know if we need to reset this though. Like, why do we do that? It says that to reset so that if it were to crash after this point, when we reconnected, we would not errantly believe these to be proper references in case we were at the beginning of the next receive iteration. In that case, it would assume this, the previous received data, was the current. So this is at the end of the receive section. In client. And what happens is we receive the data. Oop, I just moved a... Did I could have sworn it looked like I moved a line. Apparently I didn't. Okay, so we have client received data, client receive change attribute list. We reset it. So we receive this data and then we're resetting it so that at the next iteration, if we were to crash after this point, after this, when we reconnected, we would not errantly believe these to be proper references in case we were at the beginning of the next receive iteration. In that case, it would assume this, the previous received data, was the current. I don't think we need to do this. I don't think we need to reset this because it only saves once per while loop. And the while loop consists of the receive section. Like, it's going to go all the way through here. It's going to grab the receive data. It's going to pass it off to the received cal2 bliss right here, right? Isn't that what happens? The received data becomes the core data from the received data becomes client receive change attribute list. So couldn't we just refer to it as core data? Like, do we have to have this attribute called the client.receive change attribute list? Isn't that like just a middleman that serves no other purpose than to be an attribute for like so that we can know it exists, and you know, like there's no, like, what is the purpose of having this? This is the same thing on server. This is one of those instances that I've been trying to get rid of, is like middleman duplicate data points that really serve no real purpose. So let's see. Review to see if we can just refer to core data instead. So that would be ideal. And then, so we were talking about receive data becomes extracted into 3 different data points. Then we have core data, which we assign to this, and then we iterate and pass it off to the received cal tuples. Now, all this happens in the context of a single while loop. So, like, unless it makes it all the way to the next one, it's not gonna save this data. So, and we don't even save these 2 data points anyway. So we wouldn't even restore them. Like, we don't even have to worry about them being errantly restored, because as a matter of fact, we do not restore them at all. According to this. So look at this. See this? This is stuff I want to change. Well, maybe not, because I do want to. I guess it's all right. Well, no, you know what I can do? I can do like this. How about that? How about that? There we go, that's much better. Yeah, so that's not even saved at all. So there's really no reason for us to run this code. So we can get rid of this. And yep, there it goes. So we just got rid of like 20 lines right there. It's always cool. And let's go up here. And we're gonna change. Where is it? Receive data. Alright, right here. So instead of using receive change attribute list, we're just going to see if we could use core data. So let's see where all we use this. We literally, that's it. Yeah, we can just replace this with core data. Alright, so that's gone. So we're going to delete this. Okay. And why don't we use n receive? Do we use n receive on server? Or do we use con receive? Or do we use n receive? So we use con receive. And we could just use n receive because it automatically deserializes it for us. I mean, it's not that big of a deal, but I mean, it would save us. Like, we already have the function. it would save us deserializing it, you know, if that's what it does already. And I'm about that, like saving a couple lines. If a couple lines means 50%, I'm gonna do it, dude. I don't really care. You cut out 2 lines here, 2 lines there, and you do that 20 more times, and then it's a big difference. We got a lot. We're gonna have a lot here as far as logging, but it's, I mean, it's fine. Like, we can always disable the logs, right? Or we can always disable the ones that we want to disable, and you know, keep the ones that we want to keep. And isn't this supposed to be the? Why is it just? Why is it missing the from it? Confused. I just didn't copy it all the way. Okay, so yeah, and receive. What's these notes here? What's this bullshit? Concerning the below note comment, on second thought, I'm not sure this would be the issue because the ready line is supposed to only allow us to receive if there is something ready to be ready in the buffer. Right? While debugging DTM initial crash bug, consistently saw that the initial header string. While debugging, therefore I suspect that it is below line causing the bug since we added 4 seconds. Yeah, we're just not assuming any old bugs still exist. If it exists, then we'll find it. You know, it will show itself and we'll readdress it. We changed so much code, there's no point in assuming anything would be the same. Related to bugs, certainly below note, seconds I'm not sure it'd be the issue because we're down, blah blah blah. Because this line is a recurring culprit, along with other receive. The respect these lines, which call socket receive, are causing the bug since we added a 4-second wait time. There's actually nothing to immediately receive. Not 100% sure. Okay, so I mean, that might still be a problem. Hopefully, I'll be smart enough to figure that out, and I won't be like, "Oh, I shouldn't have deleted that." Fuck. You know, here's what I'll do. How about this? Well, I'll get rid of that one, and we'll keep a note. We'll copy this note here. We'll get rid of it, and then it was for the receive data line, right? Well, no, yeah, it was for that one. Okay, and then we'll leave it, but it's gonna be. Wait, what? Is it? Oh, I see what's happening. Okay, we don't want the note. We want that. There we go. Okay. Okay, so it takes in socket. Does this actually take in socket? Or does it take in connection? So yeah, should the arg So this receives the header. It gets the header amount. It receives the actual data, and then it deserializes the data, and it returns the final Python object. And I think that is I mean, that would save us. I mean, we could pass the lock as well and include the lock. We could take the lock as well, and then we would use the lock. So instead of having to have the line that utilizes the lock, we would just pass it in. I mean, that's cool. So it would save us, with passing the lock, it would save us one. Well, this is for send, right? Is this for send or receive? So there's... And why do we do parse receive header when this already does that? It's the same code. Header amount for char and header string. If char is not equal to x, header amount plus equals char, else break header amount and then return header amount. It's the same thing. So why do we use that? Why don't we just use end receive? Because it would cut this out. It would cut this out if we pass the lock. It would cut well, it would cut this out, and we would just have one line. So we would lose 1, 2, 3, 4 lines, plus it would happen again here. We would lose this. We would lose, that's 2, 3. Yeah, so that's 7 lines right there. Plus we would lose this entire static method. So that's another 11, 12, 13 lines total. So you're looking at like 17 lines lost, which is great. Yeah, like why wouldn't we? It's silly, right? Like what's the point? The main receive function using client first receives a 40 byte fixed length header. It's the same code. We just do header string. It's the same amount. It's the same exact shit. And then all we do is pickle loads and then return it. It's very simple. Yeah, let's do it. Let's get rid of it. All right, so we're gonna delete this completely. So parse received header is gonna be gone. Let me find this so I can make sure I get rid of all of it. All right, so this is. Boom. Cool. Alright. Now we have this here is going to be changed. So instead we're going to have n.receive. And we're going to have to pass in the con. And we're also going to pass in the we're going to pass in the con lock as well. Alright, and then we're gonna do deserialize receive data is equal to n receive. And now we should be able to get rid of all this, because the header amount should happen inside of n receive. Conlock application should happen in there. This can be retained. And then with serialized, con receive is going to happen in the function. And then we moved this assignment to happen. That's what it returns. So yeah, we get rid of this. All right, and let's go ahead and add the conlock to n receive. Let's change that. I'm gonna say lock conlock equals none because we don't use it. We need to fix this function. So we'll add param comments. Add param in comments and update comment overall. Let's go ahead and replace that socket with con here. So I'm pretty sure con is the more proper. Yeah. Okay, so that's alright, that's alright, so this is the other one where we would say wait, why do we hold up. We already assign reassigns con one to refer to the new con object. Oh yeah, and we have to, I found out that the assigner dictionary thing, which saves lines, is actually slower by a significant amount. So we're not gonna use it. Even though it's like less lines, it's slower. It's a good bit slower. And since this isn't going to run on a while loop over and over again, we kind of want it to be fast. So, but I was going to say we could change this to the dictionary thing, but we're not actually going to use that anymore. But I was like, if we already assign I see what we can do. We can. I got it. So we say with conlock. But wait, the con isn't even. We do need this in place since the operation endures if the other thread accesses. Like, do we actually need that though? Do we have to use the lock for this? Because this is a new connection because it's the reconnect con. And like, would they actually need access to this? Or would they, like, the other thread doesn't even know about this con yet. I mean, it is running concurrently, so it could very quickly, but it's not gonna know that until this assignment happens. But I guess the point, that's sort of the point. So how does the other thread know? Well, so this is the... Well, this is the operating thread. The other thread, though, would try to transfer to that other con object. So we would need to make sure it only tries. And that in the case that it didn't, like, it would try to send data, but then it wouldn't work, right? Because it would say something like connection refused error. It would throw a connection error, right? So yeah, I need to address that. So we'll say review server side other con DC data transfer logic, and this was me from other client threads perspective when it tries to send data after they have DC'd. How do we stop that? Because that con is dead would probably throw a connection related error. Need to ensure the data gets sent to that new client or that new con object after reconnect, and that data isn't lost. Also need to ensure the while loop continues unhinged, not unhinged, unhindered, whatever. Alright, so we have, so with conlock, and we don't need double, we can just say with conlock do this. So we have the new con, which that shouldn't, it's not going to be competed for because it's brand new, so we don't need a lock there. But then technically at this point, well, depending on how long or whatever that takes, yeah, because they're going to be accessing con 1 from the other thread, and this is really just to make sure that they can't access it until we're done assigning it, so whatever, sure. So then we have, so okay, this is fine. So we just didn't need a double, we didn't need to duplicate the with conlock, because conlock is it's universal. It's for either one of them. Alright, so then we can change this here, header amount. We're not going to use header amount. Let's see, where are we going to cut it off? Right here. So from here to here, this is going to be replaced with, we'll say deserialized received. Well, this is a different Well, it's not different in that sense though, right? It still gets received the same way, doesn't it? We pass in con and then con lock. And we have to add the code which actually uses the con lock. So we'll say if con lock is not equal to none, then we would say with con lock. And we might need to make that a reentrant lock if it's not, because that might be recursive locking. And well, no, it's not recursive, but so this should receive client ID and client type and receive con, and we pass in the con lock and we say if con lock is not equal to none with con lock, and then we just do header con receive. We receive the header. Okay, then we would use it again. Well, we don't want to do the entire thing like that, right? We'll do it like this. We'll say if con lock is not equal to none, we'll say con lock acquire. Yeah, we'll do it like this. So if con lock is not equal to none, con lock acquire, and then we'll say after we're done, we do con lock release, and then we would just reacquire it again here, and then we would re-release it immediately after because we don't need it anymore. So right there. But then we would need, so we'd have to add maybe it would be better. Maybe it would be better to do it where, well, we have to have an else, because then in that case we couldn't use the con lock. True. So we can do it like this. We'll say we want all this to happen all the time. So let's start back fresh here. We'll get rid of this con lock. Get rid of that release. Go back over here. Get rid of that. Get rid of this. Get rid of this here. So now we have, this is just how it was, right? It's receive, header string, print out the header string, header amount, blah blah blah, receive data. This was, let me just make sure. I don't want to fuck this up here. I don't want to mess it up. Let's just get rid of that. So header string. Yeah, that's how it was, just like this. So we'll just leave it. And then now we're gonna do if conlock is not equal to none, then we'll do conlock dot acquire, and then header string, or we can do with. Yeah, we'll just say with conlock, run this line, and then we'll say conlock is not equal to none with conlock, header string, and then we do else, and then we just have header string with no conlock. So if conlock is not equal to none with conlock, header string receive, and then else, which means elif conlock is equal to none, then we just receive regularly, and then we do the same thing below. We say if right here, say if conlock is not equal to none, with conlock do receive data, and then else, which is elif, same as this, we'll then just do receive data normally. Yeah, there we go. So let's review here. We have if any receive, if conlock is not equal to none, okay? So if there is a conlock, then with the conlock, we do header string equals con receive, right? Because we want to lock that con. Then else, which is either if conlock is equal to none, that's true. We just run that line without the lock. Then we print out that header string. And this should say, well, that's fine. We can say end receive, it doesn't really matter. And then header amount, this should be correct for char and header string. If char is not equal to x, so if it's a number, we add it to the header amount, and then else, once we hit the first x, that means it's over with. Then we do a break. That's right. Then we say header amount is equal to int, and then we subtract 33. I don't know why we do 33, but for whatever reason, that's what we do. Then if conlock is not equal to none, we use the conlock again to receive the header amount. That should be good. Then else, which is conlock is equal to none, we receive the data as we normally would. And then receive data unpickled is equal to pickle loads receive data. And this should be, I mean, that's fine. We can call it like this is fine. We're not going to change the name. Receive data unpickled, whatever. And then return receive data unpickled. Yeah. Alright, so that's good. Now we can go back over here. So now when we use the conlock, it will actually work. This, so normally we would have header amount equal to parse receive header. Use the conlock to just do con receive the header amount, and then deserialize it using pickle loads. Yeah, so all that's going to go away now, and all that happens in one line now. Very cool. So we'll just say internally gets header and receives data and deserializes data. Yeah, so it saves us some work. We can add this to that comment to the other one here. I knew I was going to do that. Like, I knew it, bro. Deserialize receive data is equal to end receive con lock. Yeah. And we do have to use the lock. Like, do we have to use a lock when we pass it to a function? Do we need Python 3? If we lock a con, do we need to lock it when it's passed to a function? If a con is thread safe, but if a con is not thread safe, then yes, you need to guard all concurrent access to it. Function takes responsibility to lock inside. If you want safety by default. Okay. No, I mean locking the actual line that passes the function, or passes the, that calls the function, which passes the con, even when we lock the con inside the function. You're asking if you need to lock the caller line that calls the function, even if the function already locks. Short answer, no, you don't need to lock the caller line just to call the function. If the function itself requires the lock around the con usage. Multiple threads can call write to DB at the same time. Only one thread will actually use the con at once because the lock is acquired inside. The only reason you'd also lock the caller site is if you want to group several operations together in the same critical section. Okay. Gotcha. So we don't actually have to do that. I thought we had to do that, but we don't. So whenever I pass con, I don't actually have to lock it. Because it gets locked in. I thought wrong. Let's see, lock here. So there's that many locks? Really? No way, dude. What? Hold up, man. This one says, this is what I was talking about right here. It says we need to lock the function call. But I don't think that's true. Why do we need to lock it? It says a list change attribute list, so we're just passing it. And then we pass in the change attribute list lock, but we're also locking it from the outside. So we don't actually have to do this. So we can get rid of this. Why do we use a copy? Okay, I see. That makes sense. Alright, so we do which entity list lock. So we don't need this. So we can get rid of this lock. That's gone. Now we can bump that up. There we go. Let's see if we do that again somewhere. Okay, so we're good. All right. What else? So that's fixed now. Getting rid of so many lines, dude. It's great. So is there anything else I could... What was I doing? We were doing the... I noticed receive, but what did I get sidetracked from initially? We were messing with something else. And I can't remember what it was. Can't remember. Okay, we definitely need to fix this verified ID received thing because it's different now. We have to basically review all that, the counter and the send ID, because well, we modified things that's related to it. And this can go on the line itself. Let's go right here, and I just want there to be less lines, man. Way less. This petty spaghetti. Petty spaghetti. Yeah, I remember thinking I needed to do that by time, sorting it, but I don't think that's actually true anymore. Alright, so what was the last thing we changed here? We got rid of the receive change attribute list. Then we had hopped over to server, and this should just be below line. So this is for send all, and why don't we do the same thing for end send? We don't use end send. Shouldn't we do that so that all the times we do serializing the data, creating the header, and then sending it, like we could just have this all in one. So instead of having 1, 2, 3 lines, we would just have 1 every time we sent. I feel like that would be nice just because these files are so cluttered, client and server deserve to be less cluttered. So any little improvement really does make a difference. That's the overall goal here, so that once we start testing and debugging, it's going to be really easy. We're not going to have a lot of code to look at in general. So we're below 500 lines in server. We're below we're at 350 in client, so that's pretty damn good. If I could get rid of like another 50 lines, that would be perfect. That would be great. Because that would apply to server and client. So that would knock off like maybe 10 lines in client, 10 lines in server. That's 20 lines gone. That's good. So we're probably gonna do that. Let's see about doing that. Let's say see if we can create n.send to reduce lines in server and client. And plus it's just safer because you only have one place where your problem could be. You're not going to be writing lines manually. It's all going to be like automated. So if there's an issue, it's going to show itself all the time or none of the time. You know, it's less operator error chance and more up to, you know, making sure that function's written correctly. Could reduce the lines and shrink responsibility. Yeah, there we go. All right, so I think we're gonna stop right here. We got 2 more minutes left, but I gotta piss really bad, and it's basically time to stop. And I'm kind of hungry. I need to go eat. So 2025, we stopped here. This is line 11 and things to do. Let's copy that. Let's go to devlog. And let's say stopped at line 20. Was it 20? I can't even remember that quick. It was 11. Not even close. Things to do. Alright, what else did we do? We removed client, received change attribute list. Replaced con.send calls with is receive actually. Con.receive calls with n.receive in server pi to reduce lines line usage. And then what else did we do? We made some minor. I think we made some. We changed. We got rid of the receive change attribute list, and that's pretty much all we did in that in client. Network. We modified network receive to include lock. To include a conlock param for when called from server. Alright, and then the last thing that we did thought we did something else here. That's pretty much it. Yeah, made a minor improvement, quality of life improvements. To server by n. Yep, alright, that's it. Alright, so stop time is gonna be 12:20. That's gonna put us at 1 hour and 9 minutes. We'll just say an hour. That's 24. So the date, let's copy it first and review it. So we have game testing, debugging, review, part 24. 8:20:25, 11:11 is 12:20. That's an hour 9. We'll just say an hour. Continue debugging, reviewing the game to test. This specifically removed client, received change attribute list completed from client, and use core data instead. Since it was just a reflection of it, used core data instead. Modified and receive to include a con log parameter when called from server. Replace con receive calls with n receive in server to reduce line usage. Made minor quality of life improvements to server and client. It's line 11 and things to do. Yep. Alright, so let's go to terminal. Make sure we're at the root of the project directory, which we are. We're going to get add to the branch. There it goes. Boom. Now we're going to get commit -m double quotes, paste that in there. Boom. So we had 88 insertions, 116 deletions. We added 10 lines here. We probably added 5 lines in things to do, so that's 15. So we got rid of, so we added about 70 and we got rid of 116, so we lost what, 46, roughly 45 lines. That's pretty good. So we dropped another 45. That's great. Git push. That's really good. That's what I'm looking for, dude. I want to see those lines drop. Alright, so that's going to be it. Well, we have to do a local backup, right? So let's go back over here. Make sure we do our local backup here. So we're going to open this up. Go into Programming's project. Change this date to today's date, which is the 20th. Go over here. Copy that one. Go in here. Delete the old one. Paste in the new one. And just to check, make sure it's the right one. Check that devlog. There it is. Alright, so good session. Yeah, we're getting there. It's going to take us a little bit more time, but we're almost done. We have what? How many tasks do we have left here? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And we're not going to do that one for now. So we got 14. I'll say those are 15 minutes a piece, give or take. So what you got, 14 times 15, so that's like an hour, 4, 8, 12, that's 3 hours, 3.5 hours. 3.5 hours. So about 2 more sessions. Alright, not bad, not bad. Alright, peace. See you next time.